In this video, I'll guide you through the configuration of a single area OSPF domain. OSPF stands for Open Shortest Path First. It uses the SPF algorithm to calculate the most cost-effective route to a destination. In the previous lab, we manually configured static routes to populate the routing table on our routers. There were many possible sources of mistakes, such as identifying the correct IP addresses of the next hop interface, mistakenly typing in an incorrect IP prefix and subnet. Any of these mistakes could have led to a severe disruption to the flow of traffic within our network. Routing protocols were designed to automate all the tasks we completed in the previous lab, and thereby eliminating as many sources of errors as possible. In this lab, we will configure a single area OSPF to duplicate the connectivity of the previous lab without the need to manually configure the addresses or subnets. The three routers CE1, PE1, and PE2 will be configured to be within a single area OSPF domain. We are going to assume they belong to a single ISP. We will not be making any changes to the addressing scheme. We will validate our configuration by successfully pinging every interface on every other router. We start by removing the previously configured static routes on the three routers CE1, PE1, and PE2. So we issue show router static route to see what routes we have here. We've got two static routes here, so we issue the configure router, no static route, the default route first, and the next up is the 101.11.1.1. we remove that, and then we remove the second one as well, which goes to the 140.10.0.101. We then move on to PE1, static routes. We got a few here, so again configure router, no static route 140.10.0.12/32 with the next stop of 140.10.0.102. we repeat the same thing for the 150.10.0.0/24 next up 140.10.0.98, and then lastly we go on to PE2 and do the same thing. Configure router, no static route 140.10.0.0/24 next up was 140.10.0.97. So if we issue the same command, just to double check, show router static route, we should have nothing coming up. Show router static route, all gone. Show router static route, gone. So we've cleaned up our configuration. We've removed the static route on the three routers. Next we're going to enable OSPF on all three. So we start with CE1 again. To enable OSP, we go configure router OSPF. It return. That has enabled OSPF, but we've not finished our configuration, as you'll have guessed. We're going to do the same thing on all three. Configure router OSPF, configure router OSPF. We now need to define an area. Let's go back to our diagram and see what area we said we were going to use for this. So we're going to configure a single area OSPF, and the area is going to be area 0. So let's go back to CLI and issue that command here. So our area is area 0. You could either type area 0 like that and hit return, or let's go on to the next one. You can do the same thing but differently. Area 0.0.0.0. This is the same thing. It's area 0. So area 0, do it the fast way. And then we now need to put the interfaces that we want to we want OSPF to be enabled on. So for that, the system interface has to be configured for OSPF. That's the number one thing you should always remember. The system interface always has to be within OSPF, otherwise it will not work. So let's start off by adding the system interface in our OSPF process. So again, interface. If we tab here, we'll show you all the interfaces we have. So it's very helpful, the tab. If you don't remember what interfaces you have on each router, just hit the tab, it will tell you. On this router, we've got interface going to PE1 and the system interface. So let's add the system interface first. So we've put the system interface into our OSPF process. Let's exit out of that and then do the same thing for the interface to PE1. So interface to PE1. Let's exit out of that as well. So we've added the two interfaces on CE1 into our OSPF area 0 process. We go on to PE1 and we do the same thing. So interface tab, we've got 4 interfaces on this router. We are not concerned with interface going to PE3 for now. Like I said, this will be part of a later exercise that we're gonna be performing here when we get into services, VPLSs and all that. So for now, all we need to add here is interface going to CE1, interface going to PE2, and the system interface. We will leave out the loopback interface for now. We're going to use this to demonstrate another feature of OSPF, which is like redistribution, how you redistribute connected interfaces into your OSPF process. For now, we just want to form adjacency with the 3 routers. So to do that, we continue with our configuration. So we put our system interface, exit, interface to CE1, exit, interface to PE2, enter, exit, and lastly we move on to PE2, interface, system, exit, interface to PE1, enter, exit. So what we've done now, we've enabled OSPF process 0 on CE1, PE1, and PE2. We now need to check to make sure that all 3 routers have formed OSPF neighborship with each other. So let's exit out of all this. So on the PE1, which is the one in the middle, let's issue the show router OSPF neighbor. Right. So we can see from PE1, we can see we form OSPF neighbor with CE1 and PE2, and the state is full. That's one thing you should keep your eye on. The state has to be full. So let's go to CE1 and do the same. This should only have one neighbor. Show router OSPF neighbor. This should only have neighbor to PE1. That's correct, and it's also full. Lastly, we go on to PE2, which should also have only one. Show router this also should have only one neighbor to PE1. So all we've done, like I said, we've only just enabled OSPF on the links in between CE1, PE1, and PE2. Now, we will now check the OSPF routing table to see what routes we have. For that, again, I'm going to start with PE1 because it's in the middle. It will show us a lot more than CE1 and PE1. So we issue the show router OSPF database, and again this should have a similar and also so as you can see, all three routers have identical OSPF database. That is the beauty of OSPF. All the routers will have all the routes to every destination within the network, and they will make their own decision based on the SPF algorithm. We now see that we have enabled OSPF, and it has dynamically, automatically configured the network for us. All we had to do was enable OSPF and specify what interfaces we want OSPF to run on. Next, we're going to demonstrate how we can redistribute external or connected routes into OSPF, and that we're going to use our loopback interfaces. So let's do show router interface. So as you can see, we cannot see this 140 network within our OSPF database. We can't see this 33. We cannot get to it. We can get to every other interface within OSPF apart from the loopback interfaces. Reason being, we did not enable OSPF on those loopback interfaces. For us to get the loopback interfaces distributed into the OSPF process, we have to use something called a policy. We have to configure a policy that will tell OSPF to redistribute or advertise connected routes into the OSPF process. And that's what we're going to do next. Before we proceed with the configuration of the routing policy, it's a good idea to check what interfaces and IPs we can currently reach and what we can't reach. So from PE1, I've tried to ping the system interface of CE1, and as you can see from the output, I'm getting replies. And also from CE1, I've done the same. I've pinged the system interface of PE2, which is the 150. And as you can see, I'm getting, sorry, that was a trace route. So again, the trace route also shows us how we're getting to it. So we're going from CE1, we're going straight to PE1, and PE1 is taking us to PE2. We're going to also issue the ping just to confirm. So traffic is going from CE1, it's hitting PE1, and then it's getting to PE2, and then also from PE2 it's getting to PE1, and then to the destination of CE1. Now, like I said earlier, without the routing policy, we cannot get to the loopback interface. So let's try that. So from CE1, I'm going to ping the loopback interface of PE1, which is the 140.10.0.33 IP. So let's try that. So ping 140.10.0.33. Just double check that. Yeah, that is correct. Hit return. No route to destination we're getting. So again, from PE2, Let's try and ping the same IP address. Ping 140.10.0.33. No route to destination. From PE1, let's try and ping the loopback interface. Let's see what it is. Let's try and ping the loopback interface of PE2, which is a 150.10.0.33. So from here, we issue the ping 150.10.0.33. It return no route to destination. From CE1, let's do the same thing. Ping 150.10.0.33. No route to destination. So again, let's check the PE1 loopback as well, just to make sure. We cannot get to any of those loopback interfaces because they are currently not distributed into OSPF. So to do that, like I said, the first thing we need to do is configure each router as an area border router, and that is an ASBR. And for that, we go back into our OSPF configuration. So we configure router, OSPF, it return on all three of them. Configure router, OSPF, return, OSPF, return. Next, we give you the keyword. If you tab here, we'll tell you all what you can configure under this OSPF process. But for now, we are going to just enable ASBR. We're going to play with all this in the later videos, but for now, we want the ASBR, which is area border router. So we're going to enable them as an area border router, all three of them. And that's all we need to do for that. Now we need to go and configure the routing policy. So exit out of this, exit all, exit all, exit all. To configure the routing policy, we go into configure router, policy, policy options, and we issue the keyword begin, as in we want to start configuration of policy. So we go back into the policy options, policy statement. Now we are creating a policy statement. So we go policy statement. You can name it whatever you want, yeah. But for our process, let's call it distribute loopback. So that's the name of our routing policy that we're going to use to distribute our loopback into the OSPF process. So distribute loopback. If I issue info here, there's nothing in it, it's empty. So we want to start off with the first entry, which is entry 10. Entry 10, return. We're going to say from, again, if you press the tab, it will tell you what you can do here. So action, description, from, to, as in from where to where. In our case, we're going to say from, tab. Again, tab here will tell you what you can do here. So we're going to say from, we want to say protocol direct in our case, which means any directly connected interface. So from protocol direct, it return. What action do we want? Action is, again, if you tab here, you can either reject it, accept it, roll on to the next policy. In our case, we want to accept it. Accept, it return, exit, exit all the way back to the policy options, and commit. You have to commit it, otherwise it will not take effect. So we commit it, and then we exit out of the policy of options. So exit all. We need to do this on all three routers. So again, we're going to go to PE1, configure router, policy options, begin, tab up again, but this time around backspace and take out the begin. So here we want the policy statement, and we called it, what did we call it? Distribute loopback. You could use different names, it don't matter, but for our own case, let's just make sure it's uniform. So we want to call this one distribute loopback. Again, entry 10 from protocol directly connected, action accept, exit, commit. We go to the last one, which is PE2, configure router policy options. Policy options, begin, arrow up, backspace, take out the begin, enter, policy statement, the name, distribute loop back, entry 10 from protocol direct, action accept, exit, back to the policy options, and then commit, exit all. Now we've created our policy. We now need to go back into our OSPF process and specify OSPF to use this as an export. So to do that, we go into configure router OSPF, OSPF. Now here is where we're going to say to OSPF we want to use a particular export policy. So we're going to say export, yeah, and then it's going to ask us, okay, what export policy should I use? If you tab again, because we've configured the export policy, it should show underneath here. So in some cases you'll have many policies here in a large configuration, but because this is a very small demonstration, we've only got that single policy. So again, just type the first few alphabets and tab, hit return. So we've told CE1 to use the export policy distribute loopback. We're going to do that on all of them. So exit all here, configure router OSPF, return export. We want to use our distribute. Again, configure router OSPF. Now, what policy are we using? Tab, distribute, exit all, exit all, exit all. Now let's save our configuration, and to do that we issue the admin save. I've been doing this in the background, but it's good to show you as well. So that's how you save your configuration on the Nokias. Admin and save. Admin save. Now let's check our OSPF database again. We should now have those loopback in our OSPF database. So we issue the show router OSPF database. Now, as you can see, we have a lot more external networks that have been added to our OSPF database. We can compare this with what we had before. when we issued the show router OSPF database before we configured the routing policy. So you can see the difference. Now OSPF is aware of other networks using that policy. The policy is saying anything that is connected, I'm going to distribute into my OSPF process. So to verify, we now go back to our, let's issue the same thing here, show router OSPF database. All of them should have identical databases. So let's do the same thing, show router OSPF database. Now those interfaces that we couldn't ping earlier, we should now be able to ping them from everywhere within our network. So let's start off with CE1, and we're going to ping the loopback interface of PE1, which is the 140. So we go ping 140.10.0.33. We can now ping it and get replies. We are now also going to ping the loopback interface of PE2. So ping 150.10.0.33. We can now ping the loopback interface on PE2 as well. To verify, we go to PE2 and ping the loopback interface of PE1, ping 140.10.0.33. We can ping all the loopback interfaces that we couldn't ping before, because right now our export policy is telling OSPF to include those into the OSPF routing database as well. So this concludes the configuration of a single area OSPF, and also how to use policies to distribute connected interfaces or connected networks into your OSPF database. Before we conclude this exercise, let's try and interpret the OSPF database. So what we have here is the OSPF database, and you can see the different types under the type section. And I'd like to interpret what this means to you guys. So you've got the router LSAs and you've got the network LSAs, and the AS autonomous system external LSAs are quite self-explanatory. These are the ASAs that were redistributed using the policy that we configured earlier. So anything that's got the AS external, you can tell that it was redistributed using the policies. Now, the router LSAs are the system IP addresses of all the three routers. You can see the 140.10.0.1 is for PE1, the 140.10.0.12 is for CE1, and the 150.10.0.1 is for PE2. So those are the router LSAs being generated by the routers themselves. The network LSAs are the link LSAs. And to do that, to show you that, let me issue the show router interface. Now you'll see that the like I said earlier, the system IP of PE2 is 150.10.0.1, and that is a router LSA 150.10.0.1. The link to PE1, the 140.10.0.98, that has to be a network LSA. So let's check. As you can see here is 140.10.0.98. That is a network LSA. The 140.10.0.101 is also a network LSA, but that was generated by PE1. So if we issue the show router interface here as well, you'll see that that was the interface to CE1. So PE1 has sent that to PE2 saying I've got a network or a subnet on that range, and then PE2 has put that into the OSPF database as a network LSA. Next, let's look at the routing table. Show router route table. Another thing I wanted to concentrate on here is the preference. You can see 150, you can see 10, we can see 0. The preference of 10 is being generated by remote OSPF. Any route that was learned by OSPF. Remote OSPF will have a preference of 10. Locally connected routes will have 0. Redistributed routes will have a value of 150. So that's why these values are different here. And you can see that on all three of them, all three of the routers. If we go here and do show router route table as well, you'll see different values under the preference. And the protocol type is OSPF and local. So again, anything with 150 was redistributed by our routing policy that we configured earlier. 0 is locally connected. 10 is remote OSPF. Let's go to CE1 and do the same thing. Show router route table. Again, because they have identical database, you'll see same thing but different values. So again, we've got 150 being redistributed into OSPF. The 160 was learned by OSPF, even though we were not using it, but because we had that policy configured, it picked up anything that was directly connected. That's why you're seeing this 160 there, even though it's one of the interfaces that was going to some other PE that we were not really worried about. So that's how you interpret the OSPF routing table and the OSPF link state database, just in case you're wondering what all these are. I hope you find this video useful, and thank you for watching. And please, if you've not subscribed already, kindly do so. Thank you. Bye.